All right, hi everybody. Welcome to the Lewis structures and how to draw them video. In this particular video, I'm going to cover just the rules that we should be following in order to draw our Lewis structures. And I want to go over why we're going to do each and how we're going to do each. And then we're going to go through and we're going to do two practice problems. One that uses the idea that we have to make a multiple bond, and one that just talks about how to, or one that represents how to fill octets when needed. All right, so the first thing we're going to do is we're going to calculate the total number of electrons in the structure. We're going to use valence electrons to do this. Remember that we talked a little bit about how to calculate valence electrons, but for the most part, it's the number of s and p electrons that an atom has. We're also going to then place the least electronegative atom in the center. Hydrogen never gets placed in the center. And for the most part, if you have carbon, it goes in the middle. Okay. When it comes to these structures, the types of structures that we are going to draw have a single center atom, and that means that one of them has to go in the middle. Everything else gets connected to that center atom with a single line. That's our next step. That single line represents 2 electrons. So anytime you see a line, this is 2 electrons. From there, we're going to fill outer atom octets with dots. If they need a full octet, remember that 2 dots is also 2 electrons. We call that a lone pair. The very last instruction is one that we're going to cover in the second structure that we draw today, which is going to be that if the center atom does not have an octet and you've used all of the electrons, then you have to go back and you have to make a double bond. Okay, so we're going to go through and we're going to do this for CH3I. Remember that it has 3 hydrogens, so however many one hydrogen has as far as valence electrons are concerned, we're going to multiply it by 3 to get the total number that it'll add to the structure. So we have 1 carbon atom which has 4 valence electrons. We have 3 hydrogen atoms which are going to have 3 valence electrons when you add all 3 together. And then we have 1 iodine electron which has 7 electrons to add to the structure. Now, if you aren't sure how to do the valence electrons, I'm going to point you backwards. We talked a little bit about valence electrons at the end of last chapter. So that means we have a total of 14 electrons to deal with. Our next step is to put the least electronegative atom in the center. In our case, hydrogen never goes in the center, but carbon can. So we're going to put carbon in the middle, and then we're going to connect everything to carbon with a single line. And remember that each line represents 2 electrons. So we're going to keep a running tally of how many electrons we have. Our goal is 14 electrons. If we subtract 2 electrons for each of these bonds, we have 2, 4, 6, 8 electrons to subtract. That leaves us 6 electrons total. From there, we are going to fill the outer octets. So we have 6 electrons left to add. And remember that hydrogen does not get a full octet. In fact, hydrogen only gets 2 electrons. So when we're talking about counting electrons, something I want to point out is we're going to focus on the atom we want to count the electrons around. So for instance, if we're looking at hydrogen, we would focus here. And then we're going to look at all of the things attached to it. And in reality, hydrogen should never have more than 2 electrons attached to it. So you'll see that in this one bond, this hydrogen has 2 electrons in this one bond. Every other hydrogen is the same. 2 electrons in the bond. And then right now, our iodine also only has 2 electrons in the bond. Now, unfortunately for iodine, that's not good enough. It wants a full octet. So what we're going to do next is we're going to actually take those 6 electrons we have left and we're going to add them around iodine until iodine has a full octet. Right now it has 2 electrons, so it can take up to 6 electrons more because the term octet means 8. All right, so now we have these 2, 4, ooh, that's terrible. Oh, 3, 6, 8 electrons around the iodine, including the 2 in the bond. So here's my 2, here's 2, here's 2, here's 2. So now this iodine has 8 electrons around it, which means it has a full octet. The hydrogens are all happy because they have their little adjusted version of the octet, which means 2 electrons. And this carbon, if you look at this carbon, count the electrons around it. If you just look at the carbon, okay, and you ignore everything else, the number of electrons that the carbon has is going to be 2 for each of the bonds that are attached to it. So you got 2, 4, 6, 8 electrons around the carbon. So carbon has the octet, iodine has an octet, hydrogens all have what they need. So this structure is solid, and it does have 14 electrons. If you want to prove it to yourself, count each of the lines as 2 electrons. So 2, 4, 6, 8, and then count each of the pairs of electrons as 2. So 8 was what we had before, 10, 12, 14, and that is our total. Okay, from there we have to talk about that little caveat we saw at the end of step 4, which was how to make multiple bonds. If for some reason we run out of electrons and something still doesn't have an octet, then we do want to go back and we want to make what we call multiple bonds. There's 2 different types of multiple bonds we can make. The first is a double bond and the second is a triple bond. Double bonds are pretty common. We'll find them in molecules that contain all different nonmetals. When we see a structure that has a double bond, it is counted as 4 electrons, so 2 for each line in our Lewis structures, okay? So now let's look at the carbons in this structure. If we're trying to figure out if each of the carbons has an octet, we're going to look at all the lines around the carbon. So you're going to focus on your atom, and you're going to look at 2, 4, 6, 8 electrons. That means it has a full octet. Same with this carbon, 2, 4, 6, 8 electrons. When we say they share electrons in bonds, we mean they share. So they can be counted for different atoms different times, right? So I can count this double bond as part of this carbon's octet, and I can count the double bond here as this carbon's octet as well. All right, that being said, when is it appropriate to actually make those double bonds involves the situation that you're looking at. Now, a triple bond is going to be 3 bonds between 2 atoms. In having that, you see that you've got, again, 2, 4, 6, 8 electrons around this carbon, 2, 4, 6, 8 electrons around this carbon. For nitrogen, these are missing lone pairs. For some reason, it didn't transfer to the second structure. But if you look at this nitrogen, we're going to look at what's attached to it specifically. We've got 2, 4, 6 electrons in the triple bond, and then 8 on the lone pair. Okay, so when we make multiple bonds, we can count them for multiple atoms as multiple electrons. Just make sure that when you're looking at your atoms, that you're getting that full octet. The whole reason to make multiple bonds is so that everything in your structure has that full octet if it's supposed to have the full octet. All right, so now let's do a sample where we build this molecule using the Lewis structures method, and we're going to follow our steps. Okay, so here is the molecule CH2O. The first thing we're supposed to do is calculate the number of electrons in the structure. And so we're going to go to the periodic table, and we're going to notice that carbon has 4 valence electrons. Oxygen has 6 valence electrons. And hydrogen has 1 valence electron each, and there are 2 in this particular structure. If we add all of those together, it looks like our final structure should have 12 valence electrons. All right, next step is to build our base structure. We're going to put everything that should be on the outside connected with a single bond. In the case of Lewis structures, let me redo this real quick. A lot of times, again, just like we talked about with electron dot notation, what we will do is we will draw so that everything on the 4 sides, like there's something on each of the 4 sides of an atom. So for instance, with this carbon, we're going to put a hydrogen, and an oxygen, and we're going to leave this spot down here empty because there is no atom to add. Okay? Remember, the least electronegative atom always goes in the center, and that is always carbon if it's possible. Never hydrogen. Okay? All right, next thing to do is to connect all of our atoms with a single line. We did that. And then we're going to do some accounting. So if we're supposed to have 12 electrons, so far we have added 2, 4, 6 electrons to the structure. Remember, each line is a single pair of electrons, so 6 electrons total. That leaves 6 electrons left. Okay. Now, when we go to fill the outer atom octets first with lone pairs, remember that hydrogen doesn't get lone pairs. Hydrogen is happy if it just has 1 bond. So all of our lone pairs are going to go on this oxygen. So I'm going to put my dots. So I've got 2, 4, 6 electrons with the other bond makes a total of 8 around this particular atom. Okay? Last thing to do is to look at what happens with the center atom. I've just added 6 electrons, so I'm out of electrons to add to the structure. So I cannot add 2 electrons here. That would be violating the 12 electron rule in this particular structure. So instead what I'm going to do is I'm going to try to make a multiple bond by moving an outer lone pair into a bond between 2 atoms. So I'm going to take a pair of electrons from oxygen and I'm going to put it in the bond between these 2 atoms. I'm going to redraw so that you can see that double bond down here. And then I'm going to redraw, don't forget, the 2 electrons that were left, the 2 pairs of electrons that are left over that I did not move. So now that I've done that, I've created a double bond between the oxygen and the carbon. And this is the structure I have right now. Last thing to do is to check your structures. Check them. First thing we're going to check, do we have 12 electrons? So I'm just going to count. 2, 4, 6, 8, 10, 12. I do have 12 electrons. Okay, next thing to check, octets. In other words, does everything that's supposed to have an octet, like carbon and oxygen, have the octet? And the answer here for the oxygen, I've got 2 electrons here, 4, 6, 8 electrons. So the oxygen does have an octet. What about the carbon? Does that have an octet? So let's count. 2, 4, 6, 8. So yes, it does. So that must mean that my structure is good to go. All right. So that's the end of our Lewis structures video. You are going to be practicing with these for the next couple of days. Tomorrow in class, we'll start a practice activity. And then on Friday, you'll continue and you'll have access to the answer key to check your answers as you go. So for now, you're good to go. Have a great day.